The topic that I choose is the turbine engine lubrication system. So the so turbine engine system are both wet and dry sump lubrication system that are used in gas turbine engine. Gas turbine engine oil system can also be classified as a pressure relief system that maintains a somewhat constant pressure, the full flow type of system, in which the pressure varies with engine speed, and the total loss system, used in the engines that are for short duration operation. Examples that target drones, missiles, and etc. The exhaust turbine bearing is the most critical lubricating point in a gas turbine engine because of a high temperature normally present on it. So we have two types of synthetic oils are currently used in turbine engine. First one is the type 1, the MIL-L-707808, and type 2, MIL-L-23699. Type 1 synthetic oil is an alkyl diester oil with a 3 centistoke rating. This type of synthetic oil has very low viscosity and was used primarily in early turbine engines. Type 2 naman is a synthetic oil. This is a polyester lubricant that has a 5 centistoke rating and used in a most modern turbine engine configuration. In some engines, air cooling is used in addition to oil cooling, and the bearing will support the turbine and oil cooling, referred to as a secondary flow. Is a cooling air provided by the bleed air from the early stages of the compressor. It is used to cool the turbine disc, vanes, and the blades. The use of cooling air substantially reduces a quantity of oil necessary to provide adequate cooling of the bearings. Since cooling is a major function of the oil turbine engines, the lubrication for bearing cooling normally requires an oil cooler. Next is the turbine lubrication system components. The following component descriptions include the most found in the various turbine lubrication system. Engine oil system varies somewhat according to the engine model and the manufacturer. Not all of these components are necessarily found in any one of the system. Una dyan ay ang oil tank. Although the dry sump system, the oil reservoir of a dry sump system is typically constructed of formed sheet aluminum or stainless steel and furnishes a constant supply of oil to the engine during all approved flight maneuvers. As mentioned earlier, in a dry sump system, the oil reservoir can be mounted externally or internally. When mounted internally, the reservoir might be attached to the engine case or mounted inside the aircraft structure. When mounted internally, the oil reservoir is formed by an internal space or cavity within the engine cavity. Common location for internal oil reservoir includes cavities between the major case sections and propeller reduction gearboxes. Use an oil tank that contains most of the oil supply. A small sump is usually included in the engine to hold a small supply of oil. A view of a typical oil tank is shown in it. Is designed to furnish a constant supply of oil to engine during any aircraft attitude. This is done by a swivel outlet assembly mounted inside the tank, a horizontal baffle mounted in the center of the tank, two flapper check valves mounted on the baffle, and a positive vent system. Next, all of tanks are provided with expansion space. This allows expansion of the oil after heat is absorbed from the bearings and gears, and after the oil forms as a result of circulating through the system. Some tanks incorporate oil absorbed from bearings and gears, and after oil pumps as a result of circulating through the system. Some tanks also incorporate a derailleur tray for separating air from the oil return to the top of the tank. The scavenger system. Usually these directors are the type in which oil enters a tangent. So ito is the example. Yan po. Yan. So next is the oil pump. The oil pump is designed to supply oil under pressure to the parts of the engine that requires lubrication, then circulate the oil through coolers as needed and return to the oil tank. Many oil pumps consist of not only a pressure supply element but also scavenge elements, such as in a dry sump system. However, there are some oil pumps that serve a single function, that is either supply or scavenger the oil. Scavenge the oil. The two numbers of pumping elements, two gears that pumps oil, pressure the scavenge, depends largely on the type of the model of the engine. Next is the gear pump. The pumps may be one to several types, each type having certain advantages and limitations. The two most common oil pumps are gear and gear rotor, with the gear type being the most commonly used. So meron tayong most common common oil pumps na ginagamit, which is yung gear and the gear rotor. No? Second, the gear type oil pump has only two elements, one for pressure oil and one for scavenging. However, some types of pumps may have been several elements, one or more elements for pressure and two or more scavenging. So may picture tayo sa gear pump. Ito. Yeah. Kung mapansin nyo, no, yung pink doon is from supply, and yung red pressure oil, and the green arrow scavenge oil. So dito naman tayo sa gerotor pump. The gerotor pump, like the gear pump, usually contains a single element for oil pressure and several elements for scavenging oil. Each of the elements pressure scavenge is almost identical in shape. However, the capacity of the elements can be controlled by varying the size of the gerotor system or elements. Each set of gerotors is separated by a steel plate, making each set an individual pumping unit consisting of an inner and outer element. The small star-shaped inner element has external lobes that fit within the match with the outer element that has internal lobes. The small element fits on and its key to the pump shafts and acts as a drive for the outer pre-turning element. The outer element fits with the steel plate having an eccentric bore. So, ito yung itsura ng gerotor pump. Yeah. So, next is the vane pump. A vane pump uses sliding vanes in an eccentric rotor to move fluid. The rotor drive shaft and eccentric rotor from a single rotating part driving the vanes which from the pump chambers. The sliding vanes move in and move out the eccentric motor, increasing the chamber volume when approaching the oil inlet. As a chamber rotates past the inlet, the eccentric shape of the rotor reduces the volume between the vanes and oil is forced out of the pump. Of the pump used in a oil system, the sliding vane valve is considered the most tolerant. The breeze sliding vane pumps are ideal for use to scavenge. So, ito yung itsura ng vane pump. So, next we have turbine oil filters. Filters are important part of the lubrication system because they remove foreign particles that may be in the oil. This is particularly important in gas turbine as very high engine speeds and attain the anti-friction tilts of ball and roller bearings would become damaged quite rapidly if lubricated with contaminated oil. So, yung turbine oil filters ay mahalaga siya dahil dito nasasala yung mga dumi, mga dirts, no? Para pagdating sa makina walang mga bubuo. Next, there are several types and location of filters used for the filtering the turbine lubricating oil. The filtering elements come in variety of configuration and mesh sizes. The mesh sizes are measured in microns, which is a linear measurement equal to 1 million of a meter, a very small opening. A main oil strainer filter element is shown in the left, which is ito. Yeah. Oil normally flows through the filter element from the outside into the filter body. One type of oil filter uses a replaceable laminated paper element, while other uses a very fine stainless steel metal mesh. So, next. The filtering element interior is made of varying materials including paper and metal mesh. Most filters are located close to the pressure pump and consist of filter body housing, filter element, a bypass valve, and a check valve. The filter bypass valve prevents the oil from being stuck. If the filter element becomes clogged, the bypass valve opens whenever a certain pressure is reached. So, meron tayong picture ng filter element. Ito. Next is the oil pressure regulating valve. Most turbine engine oil system are the pressure regulating type system that keeps the pressure fairly constant. An oil pressure regulating valve is included in the oil system in the pressure side of the pressure pump. The regulating valve system controls the system pressure to a limited pressure within the system. It is more of a regulating valve than a relief valve because it keeps the pressure in the system within certain limits other than only opening and the absolute maximum pressure of the system is exceed. So, meron tayong picture ng oil pressure regulating valve. Ito. Yeah. So, next is the oil pressure level valve. Some large turbofan oil system do not have regulating valve. The system pressure varies with engine RPM and pump speed. There is a wide range of pressure in the system. A relief valve is used to relieve pressure only if it exceeds the maximum limit for the system. This true relief valve system preset to the relief valve pressure and bypass the oil break to the inlet side of the oil pump whenever the pressure exceeds the maximum preset system. Next, this relief valve is especially important when oil cooler are incorporated. Bleed air from the compressor to the oil nozzle outlet. So, ito yung picture ng oil relief valve. Next, we have oil jets or nozzles. Are located in the pressure lines adjacent to or within the bearing. For compartments and rotor couplings, the oil from this nozzle is delivered in the form of automatic spray. Some engines use an air oil mist spray that is produced by tapping high pressure bleed air from the compressor to the oil nozzle outlet. This method is considered adequate for ball and roller bearings. However, the solid oil spray method is considered the better of the two methods. The oil jets are easily clogged because the small occupies in their tips. Consequently, the oil must be free of any foreign particles. If the last chance filter in the oil jets should become clogged, bearing failure usually results since nozzles are not accessible for cleaning except during engine maintenance to prevent damage from clogged oil jets. Oil jets. So, ito yung picture. Sa picture niya, meron tayong oil seal, oil nozzle, bearing. ito. Yan. Next, we have lubrication system instrumentation. Gauge connection provisions are incorporated in the oil system for oil pressure, oil quantity, low oil pressure, oil filter differential pressure switch, and oil temperature. The oil pressure gauge measures the pressure of the lubricant as it leaves the pump and enters the pressure system. The oil pressure transmitter connection is located in the pressure line between the pump and the various points of lubrications. An electronic sensor is placed to send a signal to the full authority digital engine control or FADEC control unit and through the engine indicating and through alerting system or EICAS computers and on the display in the flight deck. Conservation. The low oil pressure switch alerts the crew. The oil pressure falls below a certain pressure during the engine operations. The differential oil pressure switch alerts the flight crew of the impending oil filter bypass because the sludge filter. Second, a message sent to the display in the upper EICAS display in the flight deck. Oil temperature can be sensed at one or more points in the engine's oil flow path. The signal is sent to the FADEC or EICAS computer and is displayed on the lower EICAS display. So, meron tayong picture na ito. Yan. Sa picture, ang parts na meron ay low oil pressure switch, number 1 and 1 half, and 2 varying breather, oil filter and pressure, oil filter differential pressure switch, oil filter out pressure, oil quantity transmitter, oil pressure transmitter, engine oil pressure, number 3, bearing scavenge, oil temperature probe, FADEC, EEC oil temperature probe. No? Sa gilid naman, meron yung upper EICAS display, and sa baba, lower EICAS display. Next is the lubrication system, breather system or vents. Breather subsystem are used to remove excess air from bearing cavities and return to the oil tank where it is separated from oil mix in the vapor upon air and oil by the radiator. Then the air vented overboard and back to the atmosphere. All engine bearing compartments, oil tanks, and accessories cases are vented together so that pressure in the system remains the same. Next, the vent in the oil tank keeps the pressure within the tank from rising above or falling below that of the outside atmospheric or atmosphere. However, the vent may be routed through a check relief valve that is preset to the maintain a slight approximately 4 psi pressure on the oil to assure the positive flow to the oil pump inlet. Lubrication system check valve. Check valves are sometimes installed in the supply lines of dry sump oil systems to prevent reservoir from oil from seeping by gravity through the oil pump elements and high pressure lines into the engine after shutdown. Check valves by stopping flow in an opposite direction, prevent accumulation and undue amounts of oil, accessories, gearbox, compressor, rear housing, and combustion chamber, such as accumulations could cause excessive loading of the accessory drive gears during starts, contamination of the cabin, pressurization, air, or internal oil fires. That's the check valves are usually the spring-loaded ball and the socket type constructed for free flow of the pressure oil. The pressure required to open these valves varies from the valve generally require from 2 to 5 psi to permit the oil to flow to the bearings. Next we have oil cooler. Dry sump lubrication system requires for several reasons. Una, air cooling of bearings by use compressors bleed air is not sufficient to cool turbine bearings cavities because the heat present in the area of turbine bearings. Pangalawa, the large turbofan engines normally require a greater number of bearings, which means that more heat is transferred to the oil. Consequently, the oil cooler are the only means of dissipating the oil heat. Next, we have air oil coolers. Two basic types of oil coolers in general are used in air cooled and the fuel cooled. The air oil coolers are used in the lubrication system of some turbine engines to reduce the temperature of oil to degree suitable for circulation through the system. The air-cooled oil cooler is normally installed at the forward end of the engine. It's similar in the construction and operation to the air-cooled used to use an reciprocating engines. An air cooler is usually included in the dry sump oil system. So ito yung picture ng fuel oil cooler. Yan. Next, the fuel oil coolers. The fuel cooled oil coolers acts as a fuel oil heat exchanger in the fuel cools the hot oil and the oil seat the fuel combustion. Fuel flowing to the engine must pass through the heat exchanger. However, there is a thermostatic valve that controls the airflow, the oil flow, and the oil may bypass the cooler if no cooling is needed. The fuel oil heat exchanger consists of a series of joint tubes with an inlet and outlet port. The oil enters the inlet port, moves around the fuel tube, and goes around the oil part. So, ito yung air oil cooler. Yan. So, yun lang. Sana marami ka natutunan. Yun lang. Paalam.